Hello YouTube, this is Dazza the cameraman. Today is Sunday, February 17th, 2019, and I'm pleased to have with me again Astronomy Live. Welcome along, Astronomy Live.
Thank you. Yeah, I'm glad to be here.
Now, we're just doing this quick impromptu hangout to discuss the latest, most incredible example of ignorance from Mr. Thrive and Survive. In his latest video, which was a hangout, he posted about 2 hours ago, or it was a live video rather, called Urgent Moon Observation We Didn't Think to Look For. Could be massive discovery. Now, if you've been following my recent videos, I have responded to Mr. Thrive and Survive, who has been calling for observations of the full moon on February 19th because he's looking for signs of rotation, which of course has already been explained as what's known as field rotation. But in this video, we're going to look at something quite incredible, a massive discovery that apparently Mr. Thrive and Survive has made. So let's have a quick listen to part of his video, and then we're going to look at what he's actually talking about.
Before the moronic people jump in and say that all we're doing is proving that the Earth rotates, we get that out of the way. Now, here's the big deal. It's hard to explain. If you go to mooncalc.org, right in the middle of the day, you will find that there'll be gaps. They have a bar at the top where you can drag the sun. They can drag the timeline and see what the moon's doing with the rotation. The problem is when it's full, it doesn't show any rotation at all. It just shows a blank screen, really, a dim yellow screen. But what happens during Mooncalc is while the moon is above the horizon, you'll have a bright yellow line on that bar as you're doing it, and then all of a sudden it goes dark, like a dark gray. And the moon's still doing its rotation, but it goes dark too, and then it pops back. Now, for those of you who haven't seen it, I've seen now probably 4 videos where people have actually videoed the moon, and it just simply disappears. All right, it's there.
Well, that seems to be quite an incredible claim there, Astronomy Live. Can you think of any reason why when people are filming the moon might suddenly disappear from view?
Well, it might just set on the horizon. It might just set below the horizon.
And what if it's high in the sky? Could there be another possible reason why the moon might disappear from view?
Well, if you're talking about the Mooncalc, the one reason is if you reach the end of the day, right?
No. Before we get to that, I'm talking about an actual observation through a telescope.
Oh, yeah.
The curse of all astronomers.
Cloud cover, yes.
Cloud cover. So, you know, I'm just thinking with these videos that have been sent to him, and I haven't seen them myself, I imagine that the moon has probably been obscured by cloud cover, clouds moving across. But let's have a quick look at Mooncalc and what Mr. Thrive and Survive is talking about here. So here is Mooncalc, and we can see that I've got the location set to Miami, USA. You can see the moon phase there, and it also simulates the apparent rotation of the moon as the moon crosses the sky. We've got the phase, we've got the altitude and the azimuth angle and all that sort of thing. So we can see across the top there is this time slider. And as Mr. Thrive and Survive mentioned, we've got bright yellow here and over here. And as we move the time slider along, of course, we can see the moon crossing the sky from east to west as it does. Now that's coming up to midnight. So after midnight, we're into the next day. So I have to flick back here for the beginning of this day, same day, and we're back into the yellow. But then mysteriously, something happens that Mr. Thrive and Survive appears to be talking about, that the moon suddenly disappears from view. And you just touched on this Astronomy Live of what it could be. So the moon has gone black there. We can see this sort of faded out black silhouette there, apparently crossing the sky. But hang on a minute. What happens when I put my cursor over the moon here? And what does it say? Position of the moon under the horizon is not visible. And it would seem to me that Mr. Thrive and Survive does not understand that, you know, we can only see the moon crossing the sky, you know, our sky, and then it goes below the horizon. Would that be your take, Astronomy Live?
Yeah, absolutely. And if you can, see if you can get it back to where the moon has just barely set below the horizon. What time did that occur? So right there, you're at 4:11. If you add 5 hours, 9:11 universal time, and the moon altitude is about negative half a degree. So I've got my spreadsheet open here, set to, I don't know if you can see my screen, but set to about the same time. This is my moon calculations spreadsheet. Roughly the same location near Miami, 80.2 west, 25.75 north. And at 9:11 universal time on February 16th, moon altitude predicted to be negative 0.33 degrees below the horizon, just having set a few minutes before. If I go back to 9:08 universal time, it was at 0.05 degrees according to my spreadsheet. So what do you know? Our sources are in agreement on this, and there is a very good reason why you won't see the moon after that point in time. It's below the horizon.
Right. Now, the spreadsheet that you're presenting to us is your very own work. You've put this together from scratch. Is that right, Astronomy Live?
Yes. It took me a couple weeks to do this. It's based on basically the same algorithm you find in a lot of programs like Stellarium, Celestia, and others. It's basically I think it's ELP 2000, something like that, created by Chaprant Touzé. I'm probably not pronouncing that name correct. A French astronomer who came up with this algorithm for calculating the moon's position based on a very lengthy Fourier series, which is very, very accurate. So there's all these trigonometric equations that are copied straight out of this book. I got this book at the library. It was published in the 90s. So over 20 years ago, this book was published. You can still pick it up now, and it still works amazingly enough. If you plug in all the equations, it will calculate the moon's position. And then I added some additional equations to calculate what they call the topocentric position, the position of the moon relative to a observer standing on the Earth. Right. And from that, we get an altitude at that time, 0.05 degrees, an azimuth of 293.93, which I think will match up quite well with your moon calculator website there.
Yes, it certainly does. And I imagine in your spreadsheet, you've also included rotation of the moon. Is that correct?
Yes, yes. Right. I can paste that in here. Give me a second.
Now, can everyone in the chat see Astronomy Live's screen? Just let me know in the chat if you can or can't see Astronomy Live's screen there, please.
80.1. Let's see, 9:08 universal time. So yeah, right as it's on the horizon. According to my spreadsheet here, it should have been about 59 degrees from vertical, with the illuminated limb facing down towards the horizon.
And that would be facing the sun, of course, which is something that flat earthers never seem to notice, is that whenever you see the moon in the sky, the illuminated side of the moon is always facing the direction of the sun.
Exactly. Yep. And if we scroll down here on the spreadsheet, I actually have sun calculations as well. As you can see, sun altitude, negative 38 degrees below the horizon there. So yeah, sun below horizon. Of course, the moon's going to be facing towards the horizon with the illuminated limb, since the sun is what is illuminating. There you go.
Right. Now, Astronomy Live, I'm aware that you only have a few minutes. You need to get away. Do you have a couple of minutes just to talk quickly about field rotation of the moon?
Sure, absolutely.
Okay. Would you like to explain what field rotation is?
Sure. So field rotation occurs from any non-polar line perspective. That's the short and quick of it. But basically, what you're looking at is an apparent rotation of the moon because you're standing on the side of a rotating sphere, the Earth. And so if you're not polar aligned, for instance, if you're standing at one of the poles of the Earth, your body's going to be aligned with that pole naturally. You won't see field rotation from that perspective. But unless your body's aligned parallel to the Earth's axis of rotation, you will see field rotation relative to your local horizon. So in astronomy, if we want to take long exposures of the stars or a nebula or a galaxy, we don't want the field of view to rotate as we're taking a long exposure, which can be, several minutes long. And if you're viewing the sky from an altitude azimuth perspective, if you're viewing the sky relative to the horizon, up, tracking with the telescope up, down, left, and right, just like your head does, what's going to happen, even if your tracking is perfect, is the entire picture will appear to rotate over those few minutes of time that you took the exposure. And your stars are going to be streaked. So the only way to fix this is to align your telescope parallel with the Earth's axis of rotation. We call this polar alignment. From a polar aligned perspective, you don't get field rotation. So you're able to track all night long without the field appearing to rotate from rising to setting. This is the only way you can take very long exposure pictures of stars and galaxies. The only other way to do it is to have a motorized device that literally rotates the camera in the telescope to compensate for that. It's a very complicated solution that does exist. You can actually find products called field derotators. That's literally what they're called, field derotators, to cancel out the rotation caused by tracking the sky using two axes, using an altitude and azimuth motor. That's the only way to do that. So this is why we polar align our telescopes. Even though it takes more time, it's more tedious to get it accurately aligned with the Earth's axis of rotation physically, it makes it much easier to take deep space pictures. Right. So even when you're looking at the moon, though, if you're looking at the moon from rising to setting, even though you may not be taking long exposures, if you're taking video and you're watching it over time, you'll see it appear to rotate over time, unless you're polar aligned. During the last lunar eclipse, I had webcasts going on for several hours. The telescope was polar aligned. And so if you look back at my webcast, you can actually see that you don't see that kind of rotation. Let me share that real quick, if that's okay.
Sure, I'll just go back to screen sharing with you.
Okay. So let me see here. Let me go search for my own video here. See if it comes up. There we go. So here's my eclipse live stream. Sorry, let me mute that. Here's my eclipse live stream.
Would you like to go to theater mode? Thank you.
Yeah, exactly. So this is the start of the eclipse live stream before the eclipse started, of course. And you can see here's Mare Crisium on the right. Can you? I don't know if you can see my mouse cursor.
Yes, I can.
Can you see that? Okay, good. So you got Mare Crisium on the right of the moon. You've got Aristarchus crater here, that bright spot on the left in the middle of this sea. So those are kind of nice reference points here.
If I skip down the bottom there.
Tycho down at the bottom, exactly. Yep. So if I skip, just go ahead and skip all the way to the end here. After the eclipse, it's in the same orientation.
Right.
You've got Aristarchus on the left, you got Crisium on the right, you got Tycho on the bottom. No field rotation because the telescope is polar aligned. So no matter where you look in that live stream, it's a little harder to see as that eclipse is setting up in. But if we go to totality here, you can still see those points. You can still see Mare Crisium. You can still see Aristarchus. It's harder to see, but the Tycho is down here on the bottom. They haven't changed because I've compensated for field rotation by having the telescope polar aligned. And so this made it very nice when doing when I did a time lapse of the totality of the eclipse. I have 4K footage here from my SLR that was on the main telescope. The webcast was being shot through a white refractor that I had piggybacked on top of the main telescope, but they were both polar aligned. So I was shooting still photos through the main telescope, and you can see here's stars passing behind the moon. The moon doesn't appear to be rotating at all. It's nice and fixed and stationary because the telescope is tracking with the rotation of the Earth parallel to the Earth's axis of rotation. So you can see really beautiful there. Throughout totality, there's not a hint of any field rotation.
Right, and that was using an equatorial mount telescope, correct?
Yes, basically. Right. Well, it's the LX200 fork mount, which can be set up out as, but in this case, I had it on the wedge, and so literally, like it sounds, it's a wedge. It's an angled piece of metal that is angled at the exact same latitude that I'm at. It's tilting the whole telescope to be parallel. So if you were pointing the telescope straight up and you stuck it on the wedge, it would be pointing at the North Celestial Pole, very close to Polaris. And so that's how you align it. You basically tell the telescope, move your motors to where you think Polaris, the North Star, should be, and then you physically move the mount to get the North Star in the view. When you do that, if you've done everything right, you should be pretty close to polar aligned. And that was the case. So now, there you go.
Just very quickly, I noticed that Mr. Thrive and Survive has been rather perplexed at noticing that in time-lapse videos of the moon crossing the sky, the apparent rotation, or the rotation that he sees, seems to be slower at the start and then speeds up, and the moon sort of quite quickly does a little flip, and then after that it slows down again. Would you like to explain what's going on there?
Sure. So field rotation is not going to be occurring at a constant rate. Depends on where the object is in the sky. As it's rising over the horizon, depending on the declinations it's at and everything, it can be appearing to move more or less straight up. I mean, it's not taking too much of an angle, so it's not rotating that quickly. But as it crosses the meridian, an imaginary line from north to south in your sky, it's potentially going to rotate very quickly. It's going to appear to be, as it's on the eastern hemisphere of the sky, it's going to be potentially. So let's imagine the moon phase as it's waxing, as it's getting more full, and the sun is off in the western part of the sky. It's going to be oriented so that the illuminated portion is facing up. After it crosses the local meridian and it starts heading down towards the west, suddenly, now in this situation, the illuminated portion of the moon, the illuminated limb, is going to be facing down towards the west, where the sun is located. And so as it crosses that local meridian, depending on where you are, it can appear to rotate very quickly. In fact, this is a major problem for Altaz mounts. If you're trying to take a long exposure of the stars, like I said, you have to watch out for field rotation. If you're taking pictures of bright objects that are just coming up or setting near the eastern or western horizons, you can get away with 30-second shots without too much field rotation. But as you're crossing the meridian, if you're looking straight up, that telescope is doing almost all of its rotation in the azimuth direction. And this produces a major rotation of the field of view, even in a few seconds of time. And you can actually hear those motors starting to spin up as the telescope has to very quickly rotate over a few minutes of time to position the view to be in the western part of the sky. And so you end up with a very blurred photo if you get too close to the zenith and too close to the local meridian as objects are crossing it. So you can actually, there's a website, I forget the website, I would love to find it again. There was a website showing a chart of field rotation in degrees per hour based on the altitude and azimuth of the location you were looking at. So you could actually see a chart of where field rotation would be worse for you. And you could plan your observations around that if you're trying to get away with doing short exposures, just a few seconds long in an altitude azimuth way. And so, like I said, it's not going to be constant as it rises and sets. It's going to be changing over time. The program I released a few months ago, let me see if I can find this video again. I actually released a program to de-rotate images of the moon based on calculating the amount of field rotation that should be present. Let's see, here it is, de-rotating the moon. So I wrote a Python program. Here's a picture of an Apollo Saturn V rocket sitting on Launch Pad 39A out at Cape Canaveral, or Kennedy Space Center. This was in, I believe, 1971. And so obviously that's the only time these Saturn V's were flying. They don't fly these rockets anymore. That dates the photo right away to being decades and decades ago. And you can see a nice Cheshire moon there, very much exhibiting a lot of field rotation with the illuminated limb angled down towards the western, or I think this was in the western horizon here. And you can see, a lot of field rotation there. So I wrote a program to de-rotate this image. We know about when this picture was taken because we know the date it was taken. And the whole photo, actually, the bottom of the photo is just about at the horizon. You can see the launch platform here. And so you can actually calculate, based on the size of the moon in the image, how many degrees over the horizon it was and roughly when it was taken. So with the program that I wrote, it de-rotated that image based on that information by negative 89.67 degrees to return it to a vertical orientation. And sure enough, would you look at that, it does a perfect job. It also shows you here that at this point in the sky, the field rotation was only 0.81 degrees per hour. That's not very, very rapid because it's low in the western sky. But if it were higher, up near the zenith or the local meridian, then it would be a much higher rate of rotation. Are you still there, Dazza?
Yeah, sorry, I was muted there. Had a very noisy aeroplane flying over. That's very good. Thank you, Astronomy Live. That's amazing work that you've done there. And obviously, the acid test is that it actually works, and it works indeed.
Exactly.
Now, I certainly don't want to hold you up. Do you need to go now, or?
Yeah, I need to be taken off here pretty quickly.
Okay. Well, thank you for joining me, Astronomy Live. Great talking to you as always. And we'll catch up with you again later on. Thank you.
All right, thanks very much. Yeah, thanks for having me on.
And I'll carry on for a few minutes, a few more comments to make about Mr. Thrive and Survive and some other work that has been presented. So once again, thank you, Astronomy Live, and we'll talk to you another time. Now, I'll share my screen again. Just bear with me. Share. Just let me know in the chat. I haven't got a preview screen on at the moment, so I'm not sure that my screen share is working correctly. You should be seeing the moon with a red line on it. If you can let me know if you can see that, please. And this is from a video that I originally uploaded in 2011 explaining field rotation of the moon. Now, that was back in the days when I was debunking a lot of videos supposedly about Nibiru, and people were complaining that Nibiru, or Planet X, had caused the moon to flip on its axis. There were also other claims that Saturn and Jupiter had also flipped on their axis. So this was the video that I uploaded in 2011 explaining field rotation, and I've recently re-uploaded it again. And I use a video clip of a Concorde aircraft and some fighter jets doing a flyover in, I think it was in France. And we can see from the coloured smoke trails that the planes are actually flying in a straight direction across the sky. They're not turning at all. So let's play that, and we can see what's happening as the plane flies across, and the camera is following it. The person is rotating to follow the plane as it crosses the sky. And this is actually a perfect example of field rotation. And it's the same sort of thing that we see as the moon is crossing the sky, or even familiar constellations such as Orion. And it is, there are two things going on. Of course, we've got the rotation of the Earth underneath us, and we've also got the rotation of the observer who is following the object across the sky. So what I do next is I take some simulated photographs, and we look at those photographs. So here is a replay, and we take some shots from about here. And there's the first one, and we carry on, and we take another shot as the plane is sort of right on the meridian, so to speak, and we take a third shot there, and then we compare our photos, and it's pretty obvious what we're going to see. We're going to see rotation, just like we see with the moon, rotation of the moon. So let's compare our photos, number 1, number 2, and number 3. And that is exactly, as I say, what we see when we photograph the moon with an alt-az, that's altitude azimuth mount, which only moves up and down, left and right, instead of using an equatorial mount telescope, which actually compensates for the rotation by being aligned with the axis of rotation of the Earth. So that is what is going on. And I've previously stated in my recent videos that I 100% predict that rotation of the moon will be seen on February 19th, that's the full moon, because Mr. Thrive and Survive has requested photos taken over several hours of the full moon, unless, of course, those photos are taken with an equatorial mount telescope or tripod, which will cancel out the rotation. Now, I've tried to reach out to Mr. Thrive and Survive, as I'm always willing to try and help people if at all possible. And I mentioned in one of those earlier videos, a video by Teeth of the Lamb, who's also mentioned in Mr. Thrive and Survive's latest video. I emailed Teeth of the Lamb and offered my assistance. I also said I've got a P900 camera that I can take photos of the full moon over a number of hours. And at first, my offer was greeted with enthusiasm. But the more I tried to explain field rotation and what is going on, the more resistance I encountered from David Matthews, Teeth of the Lamb. And he made it very clear that he didn't need my assistance in the end, and that they will be doing their own research, which is fine. That should be encouraged, of course. But it became very clear that he was really seeking an echo chamber to reflect what he wants to hear. And this is what we encounter all the time with the flat earthers, of course, is that if you're in a discussion group with them, they only want to hear what supports their belief. If you try and post anything which explains what they're actually seeing, then you'll quickly find yourself being removed from the group and often blocked, banned, and so forth. So once again, Mr. Thrive and Survive, if you would like some assistance, some explanation from some real amateur astronomers using proper astronomy software and so forth, then that offer is there. I'm sure Astronomy Live would be happy to help you. And just to go back to the original point for those who have recently joined, just to recap on Mr. Thrive and Survive's amazing discovery, which he outlines in his very recent video, this one here, urgent moon observation we didn't think to look for, could be massive discovery. We played a bit of the clip earlier in this hangout. What he's talking about is if you go to Mooncalc, there's a time slider along the top there. And you'll find that part of it is in yellow, and we go down the other end here. There is the rest of it that's in yellow. But he points out that in part of it, it's actually grayed out, and the moon seems to disappear from view. There it is. It seems to be grayed out. And in his video, he suggests that people are actually seeing the moon actually disappear from view in the sky. And he states that Mooncalc actually predicts this. But what he doesn't seem to understand is that when the moon is here, it's actually under the horizon. It's gone over the horizon and is not visible, because we all know, or at least we should all know, that the moon is not visible in the sky 24 hours a day. So that is the reason why it is grayed out, because the moon is over the horizon and we can't see it. So with that, thank you for joining me, and no doubt there'll be more on this exciting topic of moon rotation. And as I stated, I 100% predict that apparent rotation of the moon will be seen in any photographs taken that are not taken with an equatorial mount telescope or tripod. So thank you for joining me, and have a good evening.